This video is about synthetic division of polynomials. And for our notes, we'll say this: we can use synthetic division to divide polynomials only when, so there's a big caveat here, only when we have a quotient of the form p of x, that's just some polynomial, over x minus c. So it's that denominator being simply an x minus some number c. That's what is the ticket to us being able to use this process. If the denominator is some other form, perhaps with a higher power of x or extra terms with it, then this will not work. So though that does seem fairly limiting, when this is applicable, it's very useful. Let's try an example where we want to divide the following quotient. We have 4x squared minus 3 divided by x minus 2. So observe here quickly that in the denominator, this is the x minus c form that we saw in the notes for synthetic division. Now, that means we're allowed to use synthetic division, but it turns out we could also use long division for a problem like this. It would work. It's just that synthetic division, when applicable, is way quicker and safer, so we're going to go that route. Now, also noticed in the numerator that, as we saw with long division, there seemed to be maybe a missing power of x in it. We have 4x squared minus 3, but if we go in descending order from the highest power down, the highest power being 2, then it seems like we're missing a power of x, a single x. So we're going to rewrite this and fill that in so that we have really 4x squared, and then we're going to say plus 0x. We saw this trick in the long division process as well. That's just holding the place for us, but we want all descending powers of x present, and then we'll keep our minus 3, and that's all still over x minus 2. So it's good to understand exactly where the missing power or the missing terms are and fill them in, because that's going to directly affect our next step. To set up synthetic division, what we're going to do is create a lonely little box, or at least part of a box, and in that box, we're going to put the c value. Now remember, x minus c is the format, which means what you're seeing in the actual denominator, the x minus 2, is the opposite of the sign for the value of c. So when we see x minus 2, that means c is actually positive 2. Now, once you put that value in the corner there, and of course, the opposite sign thing can be a trick. Just make sure you're clear on it. If it were an x plus 2 denominator, then we'd put a minus 2 in the corner, okay? But c goes in the corner. Then we're going to put, in descending order, only the coefficients of our original numerator. So since it was 4x squared plus, now we added the 0x, we're going to keep that. And then minus 3, we're just going to put the numbers 4 for the first coefficient, then just leave some space, then put a 0 for the next coefficient, and then a negative 3 after that. You're just kind of spacing these numbers out. They're not meant to make one big long number, it's just some space in between them. Then the synthetic process works as follows. We're going to leave a blank row underneath what we've just drawn, but then put a large dividing bar there just to keep things separate and organized. And then we're going to take the first coefficient we had, the 4, and simply drop it beneath the line. And then we start to bounce and multiply in the following way. This is where the rhythm or practice or process comes into play. And once you get this, it's usually pretty hard to forget. Okay, so we're going to start with our c value 2. We're going to bounce down and multiply it by the 4 that we have beneath the line, and put the result up in the next spot under the 0. So 2 times 4 is 8. We'll put that result under the 0. Now we'll add straight down. 0 plus 8 is 8. And then we start over. So now we're going to get rid of our old bouncing lines so we don't get too lost here. Now we're going to bounce the c value of 2 and multiply the new 8 we wrote and put the result underneath the next or last value we have. So 2 times 8 is 16. We'll put that underneath the negative 3 that we had there now. And then again, we'll add down vertically, just keeping the signs of the numbers we have. Negative 3 plus 16 would give us a positive 13. If you look at this result after now having gone through that whole process, it looks like a confusing mess. There are no variables anywhere. There's lots of numbers and arrows. Typically, you don't have to write all the arrows. In fact, you may not normally see those. If we just take out the arrows, it might look a little bit cleaner, but it still looks at best a little confusing with these numbers just kind of spaced out as they are. So what does all this mean? Well, the last part is to interpret our answer. Thankfully, it's always the same way, which is that what's now underneath the bar in the synthetic division process always contains at the very last entry the remainder. So our remainder is 13. And then the first number you see, so in this case 4, is always going to lead off as the coefficient of the first term in the answer. And then we go back and find the degree of the original numerator, which was squared, 4x squared. Our result is always 1 degree less than that. So if it was squared, that means the degree of our result is going to be a single x. And then we go in descending order following the remaining numbers we have for any coefficients. So we'll say plus 8 since it was a positive 8 that followed. And that's it, except for the last term, which was the remainder of 13. It was a positive 13, so we'll say plus. And remember, we always write our remainders in fraction form over the original denominator, which was x minus 2. And so there we have it. 4x plus 8 plus 13 over x minus 2 is our quotient, our final result. And that's all done using synthetic division in this case.